Hello and welcome back. In this video we are going to implement the Conway's game of life. If you don't know what that is, you can go ahead and read about it in the wiki. All you need to know is that it is a 2D game with a grid of cells, and each cell has two states. It can either be alive or dead, and each cell follows certain rules. They're described here. Well, you can pause the video and read more about it here. I will move on to implementation. I have already created the project. I have just copy-pasted the Raylib project template I've created earlier. And all it does right now is just displays a window. And I've set my FPS counter to 10. So let me show you the code. So here we are. Alright, let's start coding. The first thing we need to do is we need to add the cell size. So we have a 2D grid of cells and each cell will have a certain size. You may have, so I'll call it cell size. That will set to 12. Then we need to know the grid width, and that will be width divided by cell size, and the same for grid height. Next we need to create a cell structure. And each cell will have a certain state, alive or dead. Then each cell will have a certain color, and it will have a position as well, and size. Then we need to create a constructor to construct the cell. It will take in the X and Y position and its size. And color. Now I will randomize the cell's position in the beginning, so I will import the standard random library. And we're gonna randomize how many cells we have alive and dead in the beginning, so I will do a cast bool and then uniform from 0 to 2. And then I will just copy the data. Well, when determining the cell's position, we need to know the row and column, since it is a grid, so we need to multiply by cell size as well. And let's save the size itself. That's it. Now we also need a draw method to draw the cell. And we are going to draw only the live cells, so we will skip dead cells. There's nothing to draw. That's it, we're done with the cell structure. Now I will import a few more libraries that we will need later on. Those are standard convert, standard conf, then we will need a standard math library, and standard random, and I will remove it from here. Alright, let's continue. So the first thing that we will actually do is create cells. So we'll have a cell, and we'll have an array, a two-dimensional array. And here we will use a function called randomize color. Randomize cells. We will randomize color as well in the future. So, and we will use the default color, which is black for now. Like that. So let's go ahead and create the randomize cells function. So that will be an auto randomize cells. It takes in color as a parameter. Well, inside that function, what we are going to do is to create a two-dimensional array of cells, and then we are going to initialize each of them. So that will be ji. Well, I is the ith row and j is the jth column, so j goes into the x position and I to the y position. So j is our x and I is our y. Then it needs the cell size and the color. And at the very end we just return the cells. That's it. So what we can actually do now is we can draw those cells. And if I'm not mistaken, it should work. Oh, right here. So instead of cell size, it should be color. It should be the color. So it expects the color. So dub. And here we go. We have randomized the cells. Well, let's move on to the next stage. So vim source app. So the next thing we will do is we will actually add a pause state to our game, so that we can then modify which cells are alive and which are dead manually. So we'll add a boolean pause game, and that will be a false. And then when processing events, we will check if the space key is pressed, and if it is pressed, then we just change the state. Then what we need to do next is we need to get the mouse position. Now what I'm doing here is actually I'm trying to guess at which cell the mouse cursor points at the moment. So for example, if our X position, if mouse X position is 360, then we divide that by 12, which is our cell size, and that means that our mouse points at the 30th row. So I just write down the examples. So we have 360 divided by 12, that will give us 30. And here we have, for example, 480 divided by 12, and that will be 40. So that means that we need to look at the cell. So we need to look at the cell at this position. So let's move on to adding and removing cells. So add, remove cells, and this will be possible only if game is paused. So if pause game is true, and if mouse button is pressed. And what we will do here is just change the cell's state. And it should work now. Let's try to compile it and run it. So we pause the game, and no, it doesn't work. Ah, here it is. Here, it works. Now we can delete cells, and we can add our own cells. Now let's make that more visually appealing. So vim source app. What we will do, let's get down to the rendering. So what we will do here is, if game is paused, we will draw additional elements. Then let's draw 2 more messages. So what I would like to add is 2 operations. When we press a certain key, then all cells become dead. So it clears the field, clears the grid. And then when we press another key, it randomizes the cells again. Let's save it and let's run it. Oh. So I press space, and here we have it. So edit mode, clear, randomize. We haven't implemented the clear and randomize yet, but we can delete cells, and we can remove cells, and we can add cells. Now let's add one more feature before we continue working on those commands. So what I would like to do is whenever we draw a cell, I would like to draw the mouse cursor block at which the mouse cursor points at. So now let's save it and let's run it again. I press space and here we have it. Do you see it? Let's actually change the cell size and let's make it bigger. So what I will do and make it 120. So here's our grid. We have live and dead cells. I press space and the cell at which the mouse cursor points at is highlighted. And now we can delete cells and we can add cells. Alright, now let's work on adding the clear and randomize functionality. Now we need to return to the process events part. And add remove all cells functionality. So if game is paused and keyboard key is pressed, so press is key pressed, and that will be a keyboard key C. What we will do is we will iterate through each cell and we're going to set cell.alive to false. Now it should work. Let's compile and run it. So I press pause and then I press space and then I press C. All cells are dead. Now I add some more cells, I press C, they're dead. Now let's work on the randomize functionality. What we need to do is whenever we press R key, we would like to randomize cells. So that will be, we will add it down below. So randomize cells. So if game is paused and if is key pressed is R, what we would like to do is we would like to randomize cells again. So cells equals randomize cells. And it needs a new color, so what we are going to do is we're going to add the randomize color function. So randomize color to get a different color every time. And let's go here and implement that function. So that's it. It should work now. So I pause the game and then I press R and it randomizes. the cell's position and it adds a new color. And we can modify the result. Alright, let's get back. And the very last thing we need to do is to actually apply the rules to the game. So we will need two functions. The first function is update. So we will do an update cells. And let's get down here. So that will be an avoid update, and it will take in the current generation as a parameter. So, and we will also, and we're going to need the next generation variable as well, and that will be just a copy of the current generation. Of the current generation, so that. Then we are going to iterate through each cell. The first thing we need to do is to count how many neighbors each cell has. I will explain it in detail later, so let's just create a variable for that. And we are going to implement that function. So count neighbors. And it will take the current generation as a parameter and the current row and column. And then we need to apply the rules based on how many neighbors each cell has. According to the wiki, any live cell with 2 or 3 live neighbors survives. Any dead cell with 3 live neighbors becomes a live cell, and all other cells die in the next generation. And all other dead cells stay dead. So let's actually implement this. So if cell is dead and if it has exactly 3 neighbors, then it becomes alive. And we will save it into the next generation variable. Then, if cell is alive and if it has 2 or 3 neighbors, no, if cell is alive and it has less than 2 neighbors, or if it has more than 3 neighbors, it will be dead in the next generation. Why? Because each cell with exactly 2 or 3 neighbors survives. So and lastly, all other cells, well, if they're alive, they're alive. If they're dead, they stay dead. So we will just copy over the value. Now let's actually implement that function, the count neighbors function. So and I will create the neighbors variable and set it to 0. Now the next thing we need to do, now let me actually explain how it works. So we have a grid of cells, but what we do here is we check if the neighboring cells are alive. So the first row will be then the I-1. That will be the ith row, and that will be the I+1 row. And we also have the columns, and it is the same thing. So let's actually go ahead and implement this. So the first thing we need to check if we do not leave the bounds of our grid, that is, our row is greater than 0. And in this case, we check each column as well. So now the next thing we need to do is we need to actually check this position and this position. We do not check the position of our current cell, we check only the neighbors. And that will be if then we check if the column, the j+1 column, is within our grid, and if that cell is alive, we increment the number of neighbors. Then the last thing we need to do is we need to count how many live neighbors we have in our last row. So what we do is we check if we're still within our grid. And we should not forget to check if we're within our grid of cells down below here as well. So and we need to do the same here as well. So we're done. So this is the first row. This is the middle row, and this is the last row, the third row. And we return the number of neighbors. That's it. Now our game should work. So let's compile and run. And I press space, and then it doesn't work. Why doesn't it work? Oh, the reason it doesn't work is because we do not update the next generation. So we need to update the next generation. So the current generation. So we need to set the current generation to next generation. So we need to copy those values once we're done. So let's try again. And here we have it. Yay! Let's randomize it. Well, something's wrong. So it runs the game even though we have paused it. So let's check what's happening here. Oh, yeah, the update. So right here, we need to update the game logic only if the game is not paused. So if not paused game, like that. Now it should work. Oh. Yay! Here we have it, so let's randomize it again. And it works. So if I add, let's change the cell size again to what it was previously. So it was 12. Save and compile and run. Yay! And here we have it, our Conway's Game of Life. So let's actually randomize. And let's launch it. We can also add gliders, so let's clear it. And if I'm not mistaken, then this is a glider. Right? So let's check. Yes, it is a glider. So let's go back and resume the game. Well, congratulations! Here you have it, Conway's Game of Life. You can play around and experiment with different shapes. So, alright, that's it for today. Have a nice day and see you next time.